Okay, we are going to generate the unit circle. I'm just going to darken up my quadrantals. I'm starting with my quadrantals, which of course is where 0 degrees is. And then I'm just highlighting this a little bit darker because these are my beginning quadrantals. I'm not going to make a fancy color for those. I'm going to do those in black. If you're counting in degrees, of course, this would be 0 degrees, or if you came all the way around, we'd be at 360. In radians, that's 0 radians, or all the way around, 2 pi radians. The point that I want you to think about on this unit circle, think unit meaning 1. This would be the point 1, 0. So then now I'm going to do all the quadrantals. And since this is a quarter, it's cut into quarters, I want to think about traveling around the circle in that manner. So from 0, if I went halfway, then that would be 180 degrees because a straight line makes 180 degrees. And half of 2 pi would be pi. So in radians, that's where pi is. And then that point would be different. It wouldn't be 1, 0, because we would have gone from the origin left 1, so it would be negative 1, 0. Okay? And then if you take and cut pi in half, you have taken pi in half. So it would be pi over 2, or 90 degrees. Half of 180, 90 degrees. That point would be coming from the origin. You didn't go right or left, so the first x value would be 0, and the y value would be 1. Okay, now I'm going to count around the unit circle. 1 pi over 2, which is 90 degrees. Pi over 2, which reduces to pi. And 3 pi over 2. That's how to get your quadrantals labeled in radians. Then if you're thinking about 90, another 90 was 180, and then another 90 would be 270. That point would be 0, negative 1. Okay, now I'm going to go and talk about the reference angle of 45 degrees, or pi over 4, which I'd asked you to memorize that. So I'm going to highlight all of these references of 45 or pi over 4 in radians. Those are all my 45 references. They are halfway into each quadrant. I'm going to grab purple. I'm going to be counting instead of by 90s like I did. Half of 90 is 45. So I'm going up 45 degrees in the middle of quadrant 1. We've memorized that that's pi over 4 in radians. You can, of course, still use your conversion factor. And then, because we know something about a special right triangle, you may wish to remind yourself that the first, my parentheses looked kind of like a C, and I started to write cosine without writing a C down. The first part of your points will be cosine theta. The second part will be sine theta, meaning your x is your cosine and your y is your sine. Okay, so if I think about a 45, 45, 90, on your quiz, it will be like this sheet. It will be blank. You don't have to write these down, but I'm writing them down right now to help you see where I'm getting all these points from. If I think of this as having legs of 1 and 1, you're supposed to know the pattern n root 2. 1, 1, 1 root 2 would be easier to fill in and just give that value, those values as that, so that you can find your sine and your cosine. Your opposite over hypotenuse would give you your sine, but you can't write 1 over the square root of 2. You have to rationalize it. And so you multiply the top and the bottom by the square root of 2, the radical you don't want down in your basement, and that gives you square root of 2 over 2. So the values for x, the cosine, is the square root of 2 over 2. And the value for y, adjacent over hypotenuse, is the same thing because adjacent over hypotenuse gives you 1 over the square root of 2, which rationalizes the square root of 2 over 2. So you want to memorize that 45 or pi over 4 is square root of 2 over 2, square root of 2 over 2. If you learn the first quadrant, the rest of the quadrants are easy. Okay, so what we do is I'm going to count by pi over 4s right now, because that seems to be the hardest thing to label on here, right, is the radians. So if you say 1 pi over 4, which is 45, another 45 would give you 90, right? Think 2 pi over 4. 1 pi over 4, 2 pi over 4, but that would reduce to pi over 2. The next one is labeled 3 pi over 4. You have gone 45, 45, 45, 3 pi over 4s. Okay, does that I hope makes some sense. So I've gone 45 3 times, 3 pi over 4. Then I think, well, that's 45 into this quadrant from 90. I can either do 90 plus 45, or I can actually think more like reference angles and go back from 180, 45, which would be 135 degrees. Okay, then I think about this point. It should be exactly the same as the one in the first quadrant, except the cosine would be negative because x is negative in quadrant 2. So this would be negative square root of 2 over 2, positive square root of 2 over 2 for the sign. Then I keep counting. 3 pi over 4 is where I was at. Now I'm going to go 4 pi over 4, which is another 45, and that's pi. Then I hit the next one, will be 5 pi over 4, and that doesn't reduce, it gets labeled 5 pi over 4. And I've gone 45 into quadrant 3. So I add 45 to 180, and that's 225. And then I say, all right, the points are the same. Cosine and sine are both the square root of 2 over 2, but they're both negative in quadrant 3. So negative square root of 2 over 2, negative square root of 2 over 2. I'm going to continue now with my counting from 5 pi over 4. Okay, remember, back up here if you think about it. If you start at 0, 1/4 turn each time. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. The next would be 6 pi over 4, but that would reduce to 3 pi over 2. So the next one after that, 7 pi over 4. Okay, and then we want to say that we're back 45 degrees from 360. 360 minus 45 is 315 in degrees. Okay, don't have to worry about doing conversions, just use number sense. Okay, then this point will be the square root of 2 over 2, positive for the cosine or the x value because they're in quadrant 4, and the y part would be negative, square root of 2 over 2, which is your sine. So what I have right here is 7 pi over 4 has a cosine of square root of 2 over 2, and at 7 pi over 4, the sine is negative square root of 2 over 2. Those are the answers to sine and cosine. You've got both of them. You can get the reciprocals off those, and you can get cotangent and tangent off of those. Okay. All right, now let's go for, I'm going to do a different color now. I'm going to do my reference in green for 30 degrees. All of these are 30 degrees up from the x or down from the x-axis. That's why the reference angle is 30 degrees. I'm going to also highlight at the same time because I'm going to do all of them, the rest of them at the same time. Okay, so I'm going to highlight this other section, which is my reference of 60. I'm 60 degrees up from the x-axis at that point. Over here, I'm 60 degrees up from the x-axis that way. And in quadrant 3, I'm 60 degrees down. And in the quadrant 4, I'm 63 degrees down from 360. Okay, so let's go around here. I'm going to start with my green. This is reference 30 degrees, which we memorized pi over 6 in radians. Now I need to think about my 30, 60, 90 special right triangle if I don't have this memorized yet. So I'm going to reference my 30, 60, 90. I'm going to start with the short leg being 1, which the hypotenuse is twice that size in the pattern. Your pattern was n, 2n, n root 3. This would be 1 then, 2, and 1 root 3, or just the root 3. From that, I can get my sine, cosine, tangent, anything I want for 30 degrees or 60 degrees. Okay, so if I want to know the sine or the cosine, which is first, that's your x part, it would be adjacent over hypotenuse, so it's square root of 3 over 2. And the cosine, that was the cosine, adjacent over hypotenuse. The sine would be opposite over hypotenuse, which would be 1/2. So I just did my 30 degrees. So now I'm going to go up to, I'm going to start counting by pi over 6s or by 30 degrees. Another 30 degrees would put me at 60 degrees. So I'm right here about to finish off quadrant 1. At 60 degrees, the radian value is pi over 3, which you need to memorize. Then you can say, back to special right triangles, the cosine would be adjacent over hypotenuse. It would be 1/2. And the sine would be opposite over hypotenuse, square root of 3 over 2. So you should notice that if you know the 30 degrees, you know the 60. You just flip-flop the sine and the cosine, or the x and the y value. Okay? Now I'm going to keep counting by 30 degrees. So I went 30 to 60, 90, okay? Then I'd be at 120. And I'm still in blue. I'm on a reference of 60 because it takes 60 more degrees to get to that x-axis. Now I need to count off and figure out what my radian measure is. I know what the point should be. It should be negative 1/2 square root of 3 over 2. Because it should match this one. Okay, same position in reference. Got it? Now, the part that you want to learn now is how to radian measure, how to do the radian pattern. 1 pi over 6. 2 pi over 6. Notice that 2 pi over 6 reduced to my pi over 3. 3 pi over 6 reduces to my pi over 2. 4 pi over 6 would be this one. And I'm jotting that down, and that's okay if you do that on your quiz, but you better not put it that way in the blank. It needs to be reduced. So that would be 2 pi over 3. Now you could count from by your 60s, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. I can get that one right there if I want. Okay, so I'll show you again by reducing. So I'm going to show you 2 ways. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. And I'll show you how you can get them if you don't get what I just did. Okay? I'm going to go back to my pi over 6s now. 1 pi over 6, 2 pi over 6 reduces, so skip it. 3 pi over 6 reduces. 4 pi over 6 reduced to my 2 pi over 3. 5 pi over 6. Put that in green. 5 pi over 6 doesn't reduce. Okay, so I'm going to have 5 pi over 6 here. And I'll continue around and show you again how you can get the rest of those blue ones that I did already. This is 30 degrees back, 150. 30 degrees back from 180. Reference angle 30 degrees. This will have the same values as the pi over 6 in the first quadrant. It's going to be negative square root of 3 over 2 though, positive 1/2. Okay. All right, I'm going to continue my counting by pi over 6s. I had 5 pi over 6. 6 pi over 6 reduces to pi. 7 pi over 6. Oh, that's the next one. I'm 30 degrees down from 180, so I add 30 to 180 and get 210. The point's the same as the one I just wrote. So it's negative square root of 3 over 2, negative 1/2, because I'm in quadrant 3. Continue counting by 7 pi over 6. From 7 pi over 6 by pi over 6s. 7 pi over 6, 8 pi over 6. Notice that 8 pi over 6 would have reduced to 4 pi over 3. So you could have put it in right now. All right? I got it right here, 4 pi over 3. All right, let's continue. 180 plus 60, that would be 240. Okay, and this point will be this point flip-flopped. So negative 1/2, negative square root of 3 over 2. All your 60 should start with 1/2. Cosine or x will be 1/2. All right, we're almost done. We got one more section. So let's keep going by pi over 6s. I'm going to go back to the beginning just to hopefully catch you if you didn't get something at this point. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, but we already labeled it 5 pi over 3, because that would be 10 pi over 6 reduced. Okay, we are still 60 degrees back from 360, so that's 300 degrees. The point will be a reference of 60, so if you need to go back over here and just double check, your cosine would be adjacent over 1/2, and it's going to be positive 1/2 because x is positive in quadrant 4. And then the sine will be negative square root of 3 over 2. It's negative because sine is negative in quadrant 4, just like y is. All right, I was at 10 pi over 6. My last one to label is 11 pi over 6. Notice that if you went one more, that'd be 12 pi over 6, which would reduce to 2 pi. All of them do the same thing every time you get around. That's how fractions work. You get back to a whole number eventually. All right, so here we go. We got the last one. We're down 30 degrees from here, so this should be 330. And the point should be the same as the one that we started with, except that y value is negative. So the square root of 3 over 2, negative 1/2. So when you do your unit circle quiz, you better make sure I can read whether your signs, S-I-G-Ns, are negative or positive. Okay, it has to be there. That is your unit circle. Okay, now we're going to look at how to use it. Pardon me. Okay, this on your worksheet 18A. Okay, there's a couple ways. So what I want you to remember, all reference angles are positive. We talked about the bow tie. Theta is its own reference angle in quadrant 1. In the rest of the quadrants, the reference angle is the angle made with the x-axis, the nearest x-axis. So reference angle for theta is here. Theta is actually coming from the initial side, the positive x-axis, terminating in quadrant 2. The reference angle is with the x-axis. So you have to take 180 minus theta to get the reference angle theta with a little tick mark. Sometimes you see it with a little hat on it. That's the reference angle in quadrant 3, and here's the reference angle in quadrant 4. Makes the bow tie. Okay, the actual angles are coming from the positive x-axis. If it terminates in quadrant 4, it was over 270 degrees. And the reference angle is 360 minus theta. Okay, we talked about all that earlier. So now, what is the reference angle? Well, if you went back 3 pi over 4, if you go look at your unit circle, positive 3 pi over 4 is in quadrant 2. So negative 3 pi over 4 lands you in quadrant 3. This is where it is. Okay, the reference angle is pi over 4. And you can find the cosine and the sine right here off these points if you were asked those ideas. So that's what we're going to be doing with the unit circle. What's the reference angle for negative 3 pi over 4? Pi over 4. It's always positive, never negative. Okay. You want to give your answer in the same format as the given question. So if that's in radians, your answer has to be in radians. If the question's in degrees, your answer should be in degrees. This is terminating a negative 240 terminating in quadrant 2. The reference angle is right here. How big would that angle be? Well, if you went and added 180, you'd get negative 60, but we don't ever write a negative answer. We say the reference angle would be 60 degrees. Everybody understand where I got 60? Okay. 5 pi over 6, take a wild guess. That's how easy that is. It's here in radians almost than it is in degrees. 300, how far do you go to get back to here? Yeah, 60 degrees. Okay, this is where pi over 6 is right there. That's a reference of actually 30 degrees in terms of radians, pi over 6. Okay, there's that unit circle again. Ooh, I don't like the way that one looks. I guess it looks similar to what we did. Just another version. Convert each degree measure into radians, each radian degree measure into degrees. So on Friday, you will have a few questions like reference angles, you will still need to know, and you'll need to know how to do this, okay? These are the kind of questions that you will have on your quiz, and there is no formal quiz preview for that quiz. Not having one this time. Okay, so the conversion, do you remember what to do? Okay. Right, if you want radians to go away, you put 180 on top and pi on the bottom. If you want degrees to go away, you put degrees on the bottom, so pi over 180. All right, do I need to go over any of these? Does anybody want me to do one of these? No, maybe we should get on to something we probably find a little more difficult. All right, so let's skip those and go on to find the exact value of each trigonometric function. What I explained to you about on your unit circle already was that the points, and I've kind of jumped the gun telling you this, the points are cosine theta, sine theta. So you can get a lot of stuff off that unit circle. It's like cosine is x, sine is y, because the radius is 1, all right, on a unit circle. So we don't even have to put the r underneath. Remember how sine was y over r and cosine's x over r? Well, the r is a 1 now, so that's why cosine is x, sine is y on that unit circle. But anyway, if we want to know the sine of theta, and it's negative pi over 3, that is not what's labeled on our unit circle. Would you know where you actually are? No? You're back right here, right? Equivalent to 5 pi over 3. Positive 5 pi over 3 would have the same answer as negative pi over 3, okay? So if you were back to your unit circle, the cosine of it would be 1/2. The sine would be negative square root of 3 over 2. I'm going to show you multiple ways to get these answers, so just a moment. Okay, so we just decided the answer off the unit circle would give us the sine of negative pi over 3 would equal negative square root of 3 over 2. Agreed? All right, now let's see how we could do it. Say we didn't have a unit circle in front of us, and we weren't sure where that was. Okay, so you better know, though, that that's referenced at 60 degrees. Okay? Better know that. You better know that pi over 3 is 60 degrees. Okay, you better know that pi over 6 is 30 degrees in degrees. Pi over 4 is 45. Got to memorize those. If you went from here to here, okay, dropped a perpendicular to the x-axis, what angle would be right here if it was in degrees? That'd be 60, and this one would be your 30. And then if you said, okay, let's make the short leg 1, the hypotenuse. Now, I could draw this separately somewhere else just because I think it's getting messy. That would have been 60. This would be your 30. This would be your 1. This would be the square root of 3, and this would be 2. Okay, so then if you wanted to know the sine, you would say opposite over hypotenuse, square root of 3 over 2. Get it right off this 30, 60, 90 triangle. You with me? And then you could say, well, I'm in quadrant 4, so y is negative. Sine is negative. So this would have been negative square root of 3 over 2. Another way to get it. Okay, cosine theta, negative 135. I hope you know that that's 45 degrees into quadrant 3. That would be 45 reference angle. Didn't ask for the reference angle. It asks us for the cosine. Cosine in quadrant, all students take tangents and cotangent are the only ones that are positive in quadrant 3. So that means that cosine is negative. And you ought to memorize that any 45 degree reference, cosine and sine are the same, and they're both the square root of 2 over 2, so negative square root of 2 over 2. I'll show it one more method. Drop a perpendicular to the x-axis. This is a 45, 45, 90 triangle. This would be negative 1, this would be negative 1, and this would be the square root of 2. And there it is. Negative 1 over the square root of 2, rationalize. Negative square root of 2 over 2. Good? Multiple ways to check yourself using your 45, 45, 90s. If you, all right, couple more. Let's do tangent of 330. You know the reference would be 30, I hope. Okay, if you want to do a 30, 60, 90 special right triangle right there, say the opposite leg is -1 because it's going down. And then the hypotenuse would have been to 2, and then here would be positive square root of 3. Then you could say the tangent of 30 or tangent of 330. I guess I should have written those down on those other problems. Maybe I'll go back in a minute. Tangent of 330 would be opposite over adjacent -1 over the square root of 3. And then you need to rationalize that, which again, that was something we expected you to know how to do, prerequisite for the course. You multiply top and bottom by the radical square root of 3, and that gives you negative square root of 3 over 3 for your answer. Okay, any question about that? Now, there is another way to get it, but it's harder than this, and that would be just off of your unit circle. So let me show you how that could have worked. So if you go to your unit circle, negative 330, no, it was positive 330. 330 is right here. And tangent is y over x. We could have done -1/2 over square root of 3 over 2. Show you -1/2 divided by square root of 3 over 2. All that makes us do is take -1/2 times the reciprocal. Okay, you still get the same answer. You can do y over x, okay, from your unit circle. You just have to rationalize that then now. Okay, it's not that hard. All right, next one, tangent of pi over 4. I want to find the tangent of pi over 4. Say you forgot about your special right triangles and you went to your unit circle. Let me just show you how you can get it off the unit circle. Here's your pi over 4. It's square root of 2 over 2 for the cosine, square root of 2 over 2 for the sine, or x, y. So if you take one of those over one of those, which is what the tangent is, it's y over x, then you would have square root of 2 over 2 over the square root of 2 over 2. Agreed? That's y, that's x. And what's something over itself? Yeah, 1. Now, if you did special right triangles and you let the legs be 1 and 1, the hypotenuse would have been the square root of 2, and then you would say opposite over adjacent, tangent of pi over 4 is 1. 1 over 1. Okay, 15, negative pi over 6. Well, that's the same as positive, well, positive pi over 6 except you're in quadrant 4. Okay, pi over 6 is a reference of 30 degrees, or pi over 6 is your actual reference angle, but if you want to think in terms of degrees, then you would have -1 for your y value. I mean, or you'd have the square root of 3 here and 2 here if you're using the special right triangles. That means the tangent at negative pi over 6 is going to be opposite over adjacent. Is that the same answer I just got? Yeah? -1 over the square root of 3? Rationalized would be negative square root of 3 over 3. I think we just got that answer again, and that's because we did 330? That's why. This seems so familiar because we just did it. All right. And there's the cosine 330. We're back to the same spot. What's the cosine here? Should be square root of 3 over 2. Okay, I think that's all I'm going to do for today and let you guys have some work time. Okay, so the next questions are just like these. However, there's no pictures. Now, you can try using your unit circle to figure them out, which I recommend just because it helps you with the memorization of your unit circle. You can do special right triangles, whatever it takes. But I draw these. I mean, if you want to draw it, go for it. Because this is just going to be in here. You're going to have a 60-degree reference angle. If you want to draw it like that and go from there, why not? And you could draw yourself a 30, 60, 90 if you want. But you better know this is the 1 and this is negative square root of 3 here. So cosine's going to be 1/2. Okay, quadrantals, you might be going, well, what do I do when I get to a quadrantal like number 20? That's when you're straight down at this spot, 270. That's the point 0, -1. So what's the sign? -1. Okay, I'm going to let you practice.